In this section, we're going to be identifying quadratic functions. A quadratic function is any function that can be written in the standard form y equals ax squared plus bx plus c, where a, b, and c are all real numbers, and a cannot equal 0. So let's look at an example of a function that is a quadratic function. We have y equals x squared. This can be written in standard form, which is y equals 1x squared plus 0x plus 0. That's why it just looks like y equals x squared. In this function, a equals 1, b equals 0, and c equals 0. So now we're going to look at it in a table. We're going to look at our x and y values. So let's make a table of x and y values. We're going to have the x values of 0, 1, 2, 3, and 4. So you can see that there's a constant change in the x values of just 1. And then if we plugged in 1 into x squared, we would get 1. If we plugged in 0 into x squared, we get 0 first. Then if we plugged 1 into 1x squared, we would get 1. If we plugged 2 into x squared, we would get 4. If we plug 3 into x squared, we would get 9. And then we put 4 in x squared, we would get 16. So now let's look at the difference between those y values. Between 0 and 1, there's a plus 1. Between 1 and 4, there's a plus 3. Between 4 and 9, there's a plus 5. And between 9 and 16, there's a plus 7. So right now the difference between our y values, that would be the first difference. But now we want to look at the second difference, basically the difference between those numbers. So between 1 and 3, there's a positive 2 difference. Between 3 and 5, there's a plus 2 difference. And between 5 and 7, there's a plus 2 difference. This is a characteristic of quadratic functions. They do not have a constant first difference, which was in red, but they have a constant second difference, which is in blue. Now we're going to look at the graph of a quadratic function, which is a curve. When the graph of a quadratic function is a curve, it's called a parabola. So let's look at an example of what a parabola looks like. Now we're going to look at some characteristics of parabolas. So let's rewrite the standard form again. Y equals ax squared plus bx plus c. Now, a parabola opens upward when a is greater than 0. So let's look at what that means. A parabola opening upwards would look like now, a parabola opens downwards when a is less than 0. So let's say our equation was y equals negative ax squared plus bx plus c. Our parabola would open downward. So now let's look at an example of what a downward opening parabola looks like. Now that we know what a parabola is, we got to look at some characteristics of parabolas. The highest or lowest point on a parabola is the vertex. If a parabola opens upward, the vertex is the lowest point. If a parabola opens downward, the vertex is the highest point. So let's look at a parabola that opens upward. This parabola, a would be greater than 0, so you can see that the parabola opens upward. And the y value of the vertex is going to be the point that we just highlighted, is the minimum. Now the y value of the minimum, the y value of the vertex is the minimum. So the minimum of this would be 0. Now we're going to look at a parabola that opens downward. So if the parabola opens downward, a would be less than 0, and the y value of the vertex is the maximum. So we can see that when the parabola opens downward, our vertex is going to be at the highest point, so making it the maximum. So the y value of the vertex is the maximum. So the maximum for this graph would be 4. Now we're going to look at finding domain and range of a parabola. So unless a specific domain is given, you may assume that the domain of a quadratic function is all real numbers. So let's look at an example of a graph. So the reason the domain would be all real numbers is because as that graph continues to go downward, it'll end up taking up all the x values. If we draw it large enough, it could take up any x value that it wants to take. Now we're going to look at the range. We know that the range of a graph is based on the y values. It's basically the range of the y values possible. So for this graph, we can see that it has a maximum at when y equals 3. So we know that there cannot be a y value higher than 3. So the range of this graph would be y less than or equal to 3.